diretso ka gimeliho.
Good morning, everyone. Am I audible? Okay. Okay, so basically today will be your last class of your physiochemical processes for your this subject. Okay, so I would like to conclude whatever our left last class. So little bit was left. So let me continue from there. Okay, so last class we have done or we have discussed about the aerobic stabilization units. That is, first one was your oxidation cones. Oxidation cones and stabilization cones we have discussed. So next is your it is your oxidation ditches. Okay, oxidation ditches. Also, it is known as your extended aeration lagoons. Okay. So it is a type of like a conventional activated sludge plant. So that one we have already studied. So it is a kind of a conventional activated sludge plant, and it has been modified like to eliminate the the primary sedimentation tank and also the digestion tank of the this one activated sludge. Okay, so it eliminates the primary sedimentation tank and sludge digestion tank. Okay, just wait, some students are waiting. Let me unlock the meeting. Okay. Okay. So it eliminates your primary sedimentation tank and also the sludge digestion tank, and the process it is known as your extended aeration. And this process this treatment not treatment this process, it basically gives you like it provides a aeration tank with a very long detention of long aeration time. Okay, so the time of aeration here is a very long in when compared to the other this ditches. So the here actually what happens, the oxidation ditch plant, it is also a very economical, and here at least you can say like 1.5 lakhs population can use this oxidation ditch plant. And also it is when you compare it with the activated sludge plant or the trickling filter plant, so it is a kind of it is a very economical plant. And this plant, it also it is a it proves to be a very simple oxidation type of pond. And in the it requires a very small land area, that is about, you can say, 1/5 of the land area is required for its construction purpose. And the construction of this oxidation ditch plant, it is involving like a construction of a number of channels or ditch channels, you can say. So it involves a number construction of a number of ditch channels, and which are these ditch channels are placed together side by side, and they are having a depth of about like 1.5 meter. Also the width of the ditches, it is limited to its type, and it is also limited to its availability of the how many rotors are there, aeration rotors are used. Based on that, the width of the ditches is limited, and also it can be varying from between 1 to 5 meter. And the length of this oxidation ditch is not that much of importance, but you can like keep the perimeter of the walls of these ditches to some very minimum value, like when more than one or two ditches are used side by side, and the length, it can be varied from 150 to like 1,000 meters. So these oxidation ditches, again, it may be constructed either in earthwork or with some earthen embankments also, or also in brick or some stone masonry also can used with some vertical walls can be given. Brick masonry can also be used, or it can also be preferred, because this brick masonry, they occupy very less land area, and also this brick masonry, they doesn't get eroded. Okay, so this can be either the ditches can be of art work material, or it can be of your brick or masonry walls can also be given. So basically, what is the result that you find from this oxidation ditch is that the quality of the effluent what you are getting, it is very good. And also the removal of the suspended solids, it is also like about 95% of the suspended solids are removed, and also the BOD removed is also a very good, that is like 98% of the BOD is also removed. And what is the what is the power consumed in this process, it is also like it is more than what is required in an ordinary activated sludge process. So you are getting more power in here, more power is consumed in whatever power is consumed in an ordinary activated sludge plant. So more than that, it is consumed here. And also the cost is also like extra. Okay, so this method, it is very like it is advantageous also, you can say, for treating the where the quantity of wastewater is very less, and at places where like you have sufficient land is not available. So for constructing this large size oxidation ponds, obviously very large land area is required. But here if the land area is not sufficient also, you can construct this kind of oxidation ditches. So next is your mechanically aerated lagoons. So these these mechanically aerated lagoons, it is also a kind of your oxidation pond itself, but it is somewhat of a very greater depth. And also here the oxygen, the supply of oxygen, it is given by some mechanical aerators, and it is not it is not relying on those kind of like photosynthetic oxygen production is not there. So it is, given like mechanical aerators is given for the introduction of your oxygen in this process. So these ponds, these are very deeper, as I said, than your oxidation ponds, and they are these ponds are artificially, these are oxygens are given, and this has a very less detention period or less detention time, and also the areas are also required is less. So the depth of this mechanically aerated lagoons, these are normally, it can range between your 2.5 to 3.6 meter, and the retention time, it's also between your 4 to 10 hours. So here the land area, it is also, it's like it can be between 5 to 10% of that of equivalent of this oxidation pond, and it has like when you exceed the retention period of like 4 to 10 hours, so what happens is that the efficiency, whatever efficiency you were getting, so it will be between like 65 to 90%. So this is the aerated, and these lagoons, or these aerated lagoons, these are usually used for treating the industrial wastewaters, as well as it can be used for treating the city sewage also. Okay, so this is about your mechanically aerated lagoons. So next is your anaerobic stabilization units. So here, like the stabilization ponds, these are these anaerobic stabilization units. So these are operated under the action of anaerobic bacteria. So these are known as your anaerobic stabilization ponds, and these ponds are, they receive they get the untreated sewage. The treated sewage or not, you get it here. So they receive these ponds, they receive generally the untreated sewage, and they are also very deep, to here they are deep in that way, like you cannot, the penetration of light is not restricted in this kind of ponds. Okay, so you will not be able to see the penetration of a light, because there are growth of algae in this kind of ponds. So here, basically, anaerobic stabilization units. Your septic tank is a kind of your anaerobic stabilization unit. So septic tank is known by everyone. So it is a kind of, you can say it like it is a primary sedimentation tank also, and it is having a detention period of a very long detention period. It is having, and it is having a detention period of around like 12 to 36 hours. So it is exceeding upper a day. So it has a very long detention period, and against it has a very like a normal sedimentary tank, it has a detention period of 2 to 3 hours, like something like that. So here, though it is a primary sedimentation, you can define it as a primary sedimentation tank, but it has a very longer detention period. So, and here the extra provisions for the digestion of the sludge is also provided, and here the digestion of the sludge, it is carried out by the process of anaerobic decomposition. And here the septic tank unit, it is generally classified under the like units which work on the principle of anaerobic decomposition. So here basically the septic tank unit, it will be classified under your anaerobic decomposition principle. So, and due to this anaerobic decomposition of this sludge, so what is happening, foul gases will obviously it will evolve out, and all the foul gases will be there in the evolve in this tank, and as such this septic tank, it can be completely, it is a complete covered tank. So it is also, it is provided at a very high, where there is a vent. So a vent shaft is also provided, so that the foul gases can escape through the vent shaft. So this kind, it is known as, this is all about your septic tank in a brief. So Next is the advantages and disadvantages of the septic tanks. So here basically the septic tanks, it can be, very easily constructed, and they also do not require any supervision, or you can say they do not require any skilled persons during the construction process of this sedimentation tank. And also, there is no maintenance problem also, as it is a fixed one, and there is no periodic cleaning is required, but there is no any moving part is not there, so maintenance problem will not be coming here. And also their cost is also very reasonable, as it is, compared to the advantages and the sanitation they offer in this urban or the semi-urban areas. So here the cost is also reasonable. And also this septic tank, they function very nicely, and it can also reduce the BOD and the suspended solids also from this sewage. And also the sludge, the effluent what you were getting from the septic tank, it can be directly disposed of on the land, or also in a soak pit also. And there is not much trouble in doing this. And also these are very suited for these rural areas, where the rural areas are very isolated, and also for these isolated hospitals and buildings. So these are all best suited for all those areas. So coming to the disadvantages, so the disadvantages are that, if the tank, it is not, it doesn't function properly sometimes. So what will happen that the effluents that will be, these are obviously very foul in nature, and they are also very dark and very, they get worsened. So also these septic tank, they require very large sizes for serving many people. So it will be requiring very large sizes of septic tank. And also if there is any leakage of gas from the from the top of this septic tank, so what will happen that these bad smells will obviously, they will cause the environmental pollution. And it the periodic cleaning and this removal and disposal of the sludge, this is a very it's a tedious work, and it is also a problem in doing so. So these are the disadvantages basically of your septic tank. Now coming to the last one, that is your Imhoff tank. So Imhoff tank is basically, it is it is an improvement of the septic tank. So it is also a kind of a septic tank, but it is it is a modified, or it is you can say it is an improvement of this septic tank. And here the incoming, the whatever sewage is coming to this Imhoff tank, it is not allowed to mix up with the sludge that is produced. And also here the whatever effluent or whatever sludge is going out, or whatever outgoing effluent is there, so it is not allowed to carry like a very large amount of organic loads which are produced there. So in septic tank, what is happening is that the outgoing effluent, they are carrying very huge amount of organic loads with it. But in Imhoff tank, the outgoing effluent is not carrying any huge amount of organic loads. So this is a kind of, it is also it can be a two storage tank also. So basically this Imhoff tank, you can say it is a improvement over this septic tank, where the sludge is not allowed to mix up with the sewage is not allowed to mix up with the sludge produced. And also the effluent that is going out is also, it is not carrying any large amount of organic loads. So basically this is your Imhoff tank. Okay, so this is the end of your this treatment part. So one part is left, which I should have done it before, but I left it out that time. So that one is your about your sewers. Okay, let me. Okay, so that is about your, you already know, okay, now you already know what is a sewer. So it will be easy for you to understand now. So basically these sewers, sewer pipes, or you can say sewers, these are generally very, these are circular pipes that are, laid below this ground levels. And also they are generally, sloping continuously towards the outfall part, and also they are, designed to flow under gravity, and except for this outfall sewer, which they will carry the treated amount, and also this sewage can be pumped into the discharging sources. So, and hence it will flow this under pressure. So basically there are different kinds of shapes of sewers basically. So the sewer pipes, these are, normally circular in section, but although you can say that there can be some different sections, such as, these are the names you can see: standard egg shaped sewer, then new X-shaped sewer, horseshoe, then parabolic, then semi-elliptical, rectangular shape, U-shaped, then semicircular shaped, basket handle shaped. So these are the different shapes of sewer that is, available. Okay, so these are the you can see, these are the shapes of the sewers. Okay. Okay, so next is your, like, what are the important factors that you have to consider while, you are selecting a kind or the material of a sewer. So basically there are some, some of the factors which you have to consider while selecting the material of a sewer. So these are, like, there is, it should be resistant to corrosion. So this sewer, obviously, they contain, H2S gas. So this gas, when it comes in contact with moisture, so it can be it converts to what? It converts to sulfuric acid. So this sulfuric acid, this basically leads to the corrosion of the sewer pipes. So when you select a sewer pipe or a sewer, so it should be, corrosion free. The material should be corrosion free, so that it has a very long life of the pipe is available, is it can be sustained. Okay, so next is your resistance to abrasion. So what is happening is that the sewage, basically, it contains the suspended solids also, and the suspended solids, a part of it is somewhat inorganic, and something is, organic. So whatever part is inorganic, that means it is containing the sands or these grits and these things it is containing. So these particles, when actually they move at a very high velocity, so what they can do, they can cause, the wear and tear of the sewer pipes internally, and this is known as your abrasion. So this abrasion can reduce the thickness of the pipe, and also it can reduce the hydraulic efficiency of the sewer. Okay, by, if it makes the interior surface rough, so it can reduce the thickness of the pipe, and also it can reduce the hydraulic efficiency of the pipe. Then the strength and durability. So obviously the sewer pipe, it should have very nice strength and good strength, so that it can withstand all the forces that it comes in contact with. And these sewers, these are generally subjected to external loads also, to this traffic load is there. So these are actually subjected to this internal pressure of water also. So to withstand all these external loads and this internal loads safely without any failure, so the thickness of the pipe, it should be it should be sufficient, and the reinforcement, it is also essential. So next is your the weight of the material. Like the material, the sewer material, it should have a less specific weight, and due to its less specific weight, so it will make the pipe light, and it can be carry for handling and transportation purpose. It will be easy for that purpose. Then also the sewer material, it should be imperviousness, so that it can, there will be no seepage through the surrounding of this sewer pipes, and the material, it should be impervious. Then economy and cost also, the sewer should be obviously it should be less costly, and it should be economical. And also it is, the sewer should be, it should have a smooth interior surface, so that it doesn't have any frictional coefficient. Okay, so this is all about your sewer pipes. So this is all about your this okay, just let me see one more thing is there or not. Okay, so okay, one more thing is there. So, what are the factors that are acting on this sewer pipes? So, basically, the sewer pipes, these are some of the forces are coming in contact with the sewer pipes on a basis. Like there, it is subjected to the internal pressure also. It is coming in subjected to external loads also. Then temperature stress is also acting is playing an active role. And fractural stresses are also there. So these are the forces which are these forces are acting on the sewer pipes. Okay, and the next is your like what is the okay, how will you like test whether the sewer pipes it has some leakage or not? So it is by you can do some test like there is a test for leakage of like or water test is there. So what is done here is that the sewers are these are in the manholes. Okay, sewer pipe sections are tested between the manhole to manhole section. It is done. The test is done, and here it a pressure of about like 1.5 meter water head is taken, and here the downstream end of the sewer. It is first of all it is plugged and this water it is filled in the manhole at the upper end, and also it is allowed to flow through the sewer line. So you can basically see that the depth of the water in this manhole it is maintained at about 1.5 meter, and also the sewer line it is inspected and the joints it should be the leaks are repaired. The next test is like you can see whether there it is a test for straightness of alignment, you can say. So this test it is you can place a mirror at one end of the sewer line, and also you can keep a lamp at the other end of the sewer pipe. So if the pipeline is it is a straight pipe, so what will happen if the full circle of light will be seen at the other end. And however, if the pipeline is not straight, then it is you cannot see that a full circle of light. It would be apparent, and the mirror will also indicate any obstruction in the pipe barrel. So basically this is the test for your alignment of your sewer pipe. Okay, so this is all about your this sewers. It was a very short topic. Okay, so okay, let me provide you the attendance link. I forgot. Okay, I have provided you the attendance link in the chat box. You filled it up. I will share the material for today's class in the WhatsApp group. So this was the end of your physiochemical processes for water and wastewater treatment subject. So I hope it was not that tough, because this subject you have already studied in your 5th semester. So I hope it will be your exam will be good. Okay, so you have if you have any doubts, you can ask me later also. I will be available. Okay, you study first. After that, if you have any doubts, you can ask me later. Okay. Okay, then I'm giving you the attendance link in your WhatsApp group also. I am basically leaving. You can leave this meeting if you have filled up the attendance form.